The first step in our experiment is to blow up our water balloon. Keep in mind how large it is, as it still has to fit inside the syringe. Once you have it to a good size, just tie it off, like so, and you're ready to go.
The next step in our experiment is take your small balloon in your large syringe and drop the balloon inside the syringe and place the plunger on the end. For our first test, place the plunger at the highest point in the syringe and cover the bottom opening with your finger. Next, press the plunger down and watch as the balloon shrinks in size. Remove your finger from the bottom of the syringe to release the pressure. For the second test of our experiment, we're going to place the plunger at the lowest point it can be without touching the balloon. Once again, place your finger over the opening in the bottom of the syringe and pull the plunger upwards. Watch as the balloon increases in size. To release the pressure, remove your finger from the opening in the syringe. When pressure increases, volume decreases, and as pressure decreases, volume increases. In our experiment, the balloon and syringe are filled with tons of gaseous air molecules. Placing your finger over the opening at the bottom of the syringe keeps the mass of air molecules constant and creates a closed system that will allow us to manipulate the pressure and volume. When we press the plunger down, we are increasing the pressure being placed on the air molecules inside the syringe by reducing its volume. As the pressure increases, the amount of force placed on our air molecules increases and they are forced closer and closer together, decreasing the volume of space that our gas takes up and shrinking the size of our balloon. When we remove our finger from the bottom of the syringe, we release the added pressure and our balloon grows back to its original volume. In the second portion of our experiment, we start with the plunger at the bottom of our syringe, almost touching the balloon. When the plunger is pulled upwards, we are reducing the pressure inside the syringe by increasing the volume of space the air inside takes up. This decrease in pressure and increase in volume pulls the air molecules further apart, increasing the amount of space the gas takes up, growing and expanding the size of our balloon. Removing your finger from the bottom of the syringe returns the pressure back to normal, reducing the volume and size of our balloon. When we compare the two variations of this experiment side by side, we can clearly see the inversely proportional relationship between the volume and pressure of an ideal gas. This relationship is known as Boyles'Law.